Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! For this question, it's really important that we understand what the words sum and product mean. Now, sum just means add, and product just means times. So we're going to start by adding the 5 and the 4. So that will equal 9. And then what we're going to do is find the product of 9 and 7. So we're going to multiply them together. 9 times 7, which is 63. So our answer is 63. So I'm going to just copy that number down again, just make it a bit bigger so we can see what we're doing. Okay, we're asked to work that out, round it to 3 significant figures. That means 3 numbers from the left-hand side. So starting here, 1, 2, 3. Now, the first number has to be not a 0. So if it was a decimal, we would start counting as soon as it wasn't a 0. After that 4, then we're going to put a line down. Now all the numbers are going to turn into 0 on the right hand side. So these numbers here will all turn to zeros. But before they do, we need to look at this number. Now this number is a decider number. If it is 5 or more, then it will push this number up by 1. If it's less than 5, then nothing will happen. Because it's less than 5, all the numbers to the right will turn into zeros. And with decimals, if they're zeros, we don't need to write them. So the answer would be 30.4. Something to realise in this table we're given in this question is that the triangle has 3 sides, quadrilateral 4, pentagon 5, and hexagon 6. And that number is just 2 less than the number of faces. So basically, if you've got the number of sides, you add 2. So 4 plus 2 is 6, 5 plus 2 is 7, and 6 plus 2 is 8. So if we've got 20 sides, and we just do the same thing, so we're just adding 2, then we should have 22 faces. So our answer is 22. If you imagine these numbers written out as a list, there would be 5 lots of zeros, so 1, 2, 3, 4, 5. There'd be 9 lots of 1, so 1, 1, etc., etc. Okay, so when we're looking to see the total number of goals scored in the season, we could write them out as a list and then add them up. But a quicker way of doing that is just multiplying the amount of goals by the frequency. So we've got 5 lots of 0 goals, which will just be 0. 9 lots of 1 goal, so that's just 9. 4 lots of 2 goals, so that's 8. 6 lots of 3 goals, that's 18, and then 6 lots of 4 goals, that's 24. So all we need to do now is add up the 0, 9, 8, 18 and 24, which brings us to 59. So there were 59 goals scored. The first thing to do when working out what angle things need to be on a pie chart is to add up the frequencies. So we're going to do 14 plus 7 plus 3, and we find out that that's 24. Then we're going to find the angle that one item would be. So one item is going to be, well, there are 360 degrees in a triangle, and there are 24 items. So we're going to do 360 divided by 24, and that gives us 15 degrees. So each item is worth 15 degrees, or will take up 15 degrees. So to find out the angle for red, well, we've got 14 items, times it by 15, and that will give us 210 degrees. And we're just going to times each of these by 15, which would be 105, and the final one times 15 is 45 degrees. Add them up, and they add up to 360, which is good. They need to add up to 360. So we get our protractor, rest it on a pie chart. Now we know 180 is down here, so the first thing we're going to do is just mark that on, because the first angle is going to be 210, so we know that's 180 so far. So I'm going to turn my protractor around, and from 180, 210 will be another 30. So I'm just going to plot that on, and then I'm going to join it up. So start at the center and join that up, and we're going to stop when the circle stops. Then to do 105, we're going to put our protractor in the middle, and we're going to look at 105, which will be up here, and then we're just going to join it up with a straight line. And then we're just going to check the last angle, and so if I put my protractor on it, and it is 45 degrees. Perfect. Now, an important step to not miss is you need to label them. And so the first one is red, the second one is blue, and then the final one is other. This coordinate is telling us to go 2 to the left from the center. We go right when it's positive, we go left when it's negative, so it's 2 to the right. And then it's telling us to go 1 up. It's up because it's positive. So we need to go 1 up, and we get to the coordinate of B. So the coordinate we get to is B. And so we just look at the -2 on the x-axis and the 1 on the y-axis, and that is where point B is. The key says that a circle represents 8 DVDs, but if we cut this into 4, each quarter represents 2. So we're looking to see how many DVDs were sold on Wednesday. So that would be 8 for this one, and then it's 2 per quarter. So 8 plus 2 is 10, plus 2 is 12, plus 2 is 14. So the answer is going to be 14. To answer this question, we basically need to find the lowest common multiple of the 10 minutes here and the 15 minutes here. So we're going to start off just by doing the 10 and 15 times table. So it'd be 10, 20, 30, and 15 times table with 15 and 30. So the lowest common multiple is 30. So after half an hour, these buses will sync up. They'll both leave at the same time. And all buses start service at 9 o'clock. So it will be half an hour after 9 o'clock, which will be 9:30. The lowest point on this graph is here, and that's at point 6, and the highest point is here at point 20. And we're looking for percentage change or percentage increase, and the formula is change over original times 100. So the change between the 6 and the 20 is 14. The original, the starting point, was the 6, and times by 100. And that gives us 233.333 blah 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 percent. And this 100 technically is 100% that we're timesing it by. So it says it wants it to the nearest percent, so that would be 233%. The first piece of information I'm going to focus on is the fact Denver gets 8/19. Denver gets 8/19, that means that Engel and Fido together must get 11/19 because they have to add up to 1. So we're only looking at 11/19. I'm going to focus on the ratio next of Engel to Fido. So it's 9 to 5. And let's have a look and see, well, first of all, how many parts there are all together. So 9 plus 5, which is 14 parts. So there are 14 parts in total, and the share that they get is 11/19. So what I'm going to do is to find out what fraction one of those parts is worth by dividing 11/19 by 14. So each part is worth, and I'm just going to keep this into my calculator, 0.041 blah blah blah. And we're asked to find Fido's share. Well, Fido has 5 parts. So Fido has 5 parts, each of them worth 0.041 blah blah blah. I've kept it in my calculator to keep the accuracy, and when I do that I get 0.206 blah blah blah. Now we're asked to work it out as a percent, So I'm just going to times that by 100. So we have 20.676 blah 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 percent, and it wants it rounded to the nearest percent, so that would be 20%. Or actually it would be 21%, because this would round it up, so 21%. You will need to use a paper and pencil to do this physically. You can't really do this on the computer. And make sure you have a ruler and a compass. So the first thing we're going to do is draw our 10 centimeter line. And we're going to get our compass and we're going to measure the 6 centimeters for the left hand side. So we're going to measure 6 centimeters on our compass. And we're going to just put a little arc there. We can do the same on the other side for 8 centimeters. So we're going to do our 8 centimeter arc from the right hand side, and we're going to put the point of the compass here. And it should be like that. And you can see where the two arcs overlap, which is here. And we can join these up with straight lines. And it says to measure the angle X, so we're going to need a protractor for this bit. I'm going to put our protractor here with the crosshairs matching here. So we're going to be looking at the inside, the outside one, and it comes up as 37 degrees. So our answer is 37 degrees. So the pass mark for the test is here, and we can see that there are 2 students who passed the test. So it's 2 students out of 2, 3, 4, 5, 6, 7 in total. And we want this as a percentage, so we're going to times it by 100%. So we do 2 over 7 times 100, and that gives us 28.571 blah blah blah. And it says it wants it to the nearest percent, so that will be 29%. So we've got to first of all find out what the gradient is for our graph. So we're just going to pick 2 points and draw a triangle between them. So I'm just going to pick this point here and this point here, and there's no reason I picked those, just pick those at random. And we look at how far it's going to cross, so it's gone across 10, how far it's gone up, so it's gone from 24 to 36, so it's gone 12 up. And to work out the gradient, which you can call n, or you can just write out the word gradient, it's change in y over change in x. So how much has y changed over how much has x changed? So y is this one here, so it's changed by 12, and x has changed by 10. So it's 12 divided by 10, which is 1.2. Now a gradient represents the amount of change in the y per one change in the x. So for every 1 mile we travel, we're going to go up, it's going to cost 1.2 more. So the interpretation that we give for this context, because this is about taxis, is that the taxi will cost £1.20 or 120 pence per 1 unit on the x per mile. And that's true for the gradient for any context. It's for every one of this, how much of this increases, how much the y increases by. The midpoint of a line is just the halfway point of the line, and we can see that the halfway point will be here. And so the coordinates of that point are 0, 2. So we have an original amount, and this represents 100% of the original amount. The new price, new amount, represents 113% because it has said that it has gone up by 13%. So it has increased by 13%. And as a value, that increase is £1,287. So it's 13% of the original. It's gone up 13% of the original price. So what we're going to do is we're going to work out what 1% of the price increase is. Instead of 13%, we're going to work out what 1% is. And we're going to do that by dividing the amount by 13, and we get 99. So 1% represents £99. So 1% of the original represents £99. But the new amount is 113%. So we need to times the £99 by 113, which gives us £11,187. So the picture is now worth £11,187. To answer this question, we're going to have to create a two-way table for all the information. So I'm just going to draw a quick table. So we've got maths, English, science, then a total column. And then across here we have male and female and a total column. Okay, so going to fill in maths at the top, English, science, and then we have a total. And then we've got male, female, and then total at the bottom. So looking at the information we have, it says there are 43 students who are male. So altogether the total male is 43. 30 out of the 52 students who went to science were female. So we're just looking at science, and 30 were female, and it says there were 52 altogether. 37 students went to English, so total for English was 37. And then 17 females went to maths. So looking at maths and females, which would be there. So that's all the information we're given, apart from the 115 as well. There we go. So we start filling these in. So looking at these two, if there are 115 students altogether and 43 were male, that means 72 will be female. Looking along the bottom here, the total of English was 37, the total of science was 52, and the total altogether 115. And notice I'm not necessarily reading the question here, I'm just filling out the two-way table, but we'll read the question at this point. So it says work out the number of males who went to English. Males who went to English will be this box here, so this is our target. But you can't work that out directly, we've got to kind of go around and work out what we can. So the next thing we can do is work out this bit here. So the total females 72, the females who went to maths 17, the females who went to science 30, so that leaves 25. And then you can see here we can work this out. So the total was 37 who went to English, 25 females, and so that means there will be 12 males. There are a number of different ways of working out this question. You can find out the amount of tissues per penny. You can work out the amount of, or the price of one tissue, or you can get all the amount of tissues into the same amount. I'm going to find out the price per one tissue. And we're going to start off with the 24. And what I'm going to do is I'm going to convert the money into pence, just to mean that we don't have as much decimal. And we're going to do 807. I'm going to divide by the 24 to find out the price of one tissue. So that is 33.625. And so I'm just going to round that to 33.63. I'm just going to round everything to 2 decimal places, which it says in the question. Next one, we're going to do the 20 soft tissues. So this time I'm going to do 683 divided by 20. When I put that into the calculator, you get 34.15, so that's already 2 decimal places. And then finally we're going to do the 15 soft tissues. So we're going to do the 623 divided by 15 to find the price per tissue. It should be 41.533 blah blah blah, and rounded would be 41.53. So if you buy 15 tissues, it will cost 41 pence. 20 tissues, it will be 34 pence per tissue, but 24 tissues will be 33.63. So that's by far the cheapest. The best value is the 24 tissues box. Now, there's such thing as buying in bulk. Generally, the more you buy of something, the cheaper it is. Don't rely on that. Both in the GCSE, both in the exam, and in real life. Sometimes in real life, if you buy more of an item, actually per tissue, sometimes it becomes more expensive, especially if there's a special offer on the smaller box. To get from the length of a square to the area, we square the length. To work backwards, what we do is we square root, because the inverse of square is square root. So we've got 196, and we're going to square root it to find the length. So we work out the square root of 196, which is what number times itself is 196. And you should learn them from 1 to 15, so you should know all of the square numbers from 1 to 15. So you should know that the answer is 14. So the length, therefore, is 14. So to work out what the perimeter is going to be the distance around the square. So if I draw a square out, we know that each of these lengths are 14. So it's just going to be 14 times 4, which will be 56. So we have a set of vertically opposite angles here and here. And we're going to start with those because we have to find out what m is before we can work out what x is. And vertically opposite angles are always equal, so we've got 13m plus 39 is going to equal 2m plus 149. And we're going to get our lines in there because we're going to solve this. And to solve this, we first of all take away the smaller amount of m, because we've got m's on both sides. We can't really cope with that when we're solving. And so we've got a 13m and a 2m. So we're going to remove the 2m. We're going to take that away from both sides to start off. And so we're left with 11m plus 39. And we've just got the 149 on the right hand side. Next we're going to remove the number. So take away 39 from both sides. And we've got 11m is equal to 110. And then we're going to divide both sides by 11 to find out what m is. So m therefore equals 10. So we know if m equals 10, we can then work out x. And the way we can do that is the fact that this one and this one are both on a straight line. So they are both on this straight line here. So we know that they've got to add up to 180. So let's write that down. 13m plus 39 plus x is equal to 180 degrees, or I don't normally put that in for the working out, I always put that in for the answer. So we can solve this, or well, first of all we know what m is, so it'd be 13 times n, which is 130, and then we can solve this. So let's get my solving lines in. And so that's going to be 169 plus x equals 180. And we're going to just take that away from both sides, the 169. So we've got x equals 11. So the value of x will be 11 degrees. So what we do is we notice that to get this 10, we add the 3 and the 7. To get this 17, we add the 7 and the 10. And to get this 27, we add the 10 and the 17. Whenever we have this kind of sequence, it's called a Fibonacci sequence. You essentially add the previous two terms to get to the next term. And so what we need to do is just simply add the 17 and the 27. When you do that, you get 44. So our next term is 44. So we're going to track the amount of eggs to make the amount of, or to make each amount of omelette. So 5 eggs makes 17 omelettes. And we're just going to find out how much is required, how many eggs is required to make 1 omelette. So we divide that by 17, divide both sides by 17. And so 1 omelette would be 0.294 blah 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 eggs. Next we want to see how many for 67 omelettes. And to get to 67 from 1 times 67, so do that to the amount of eggs, and we get 19.705 blah blah blah. Now you can't get 0.705 of an egg, we always round with eggs, and we always round upwards, because if you need 19.7, 19 won't be enough, so we need to pick 20 eggs. To find the average rate of petrol usage, which I'm just going to call rate, what we're going to do is we're going to get the distance travelled by the car, and we're going to divide that by the amount of fuel used, so the volume of the fuel used. So the distance was 135 kilometres. The volume of the fuel used was 9 litres. We do 135 divided by 9, which is 15. So it's 15, and this was in kilometres, and this was in litres. So it's going to be 15 kilometres per litre. To find the exterior angle of any polygon, we do 360 divided by the amount of sides. These are decagons, which means they have 10 sides. So the exterior angles will be 36 degrees. And the exterior angle is just an angle that kind of continues on. You just continue on from the side. So this one here is the exterior angle of the left-hand decagon, and this one here is the exterior angle on the right-hand decagon. So altogether, the angle A will be 36 plus 36, which will be 72. So our answer will be 72 degrees. So trying to describe the single transformation, it kind of looks like it could be a rotation, and it would be a rotation of 180 degrees. But if it was a rotation, it would be actually this way around. And so it's not a rotation. It looks to me like it's a reflection, which it is. Now we've got to find out where we put our mirror line, and our mirror line for this would be a horizontal line. So if I just guess and I put it down here, notice that B is only 1 jump away from that, and yet A is 1, 2, 3 jumps away from that. So that's not very good. That's not the halfway point. So we need this to be the halfway between the two shapes, which is going to be here. And the name of that line, well, everywhere along that line, y is equal to -1. So we call it the y equals -1 line. So it's going to be a reflection across line y equals -1. In this question we've got euros and we've got pounds, and we're told that £1 is 2.23 euros. And we're trying to get to understand what 2,676 euros is in pounds. And we're going to do that by finding out what 1 euro is, and then finding out how much 2,676 are. So to get from 2.23 to 1, we divide by 2.23, and we're going to do that on both sides. And when we do that, we get 0.448 blah blah blah. And then to get from 1 to 2,676, we go times by 2,676 on both sides. And when we do that, we get £1,200. So 2,676 euros is £1,200. It's really important when answering this question that we're really methodical. So we're going to start off just looking at stake, and so I'm going to start off with the S, and we're going to pair it with the first dessert, which is the I. Then we're going to pair the steak with the second dessert, which is the mousse. Then we're going to pair it with the third dessert, which is the fruit. So we're being really methodical. We've done all of the combinations with steak. And so we're going to look at burger next. And we're going to pair it with the first ice cream. Then burger. And we're going to pair it with the mousse. And then finally the burger we're going to pair with the fruit. As long as we do things methodically, we don't ever miss any. So 7 times 10 to the power 4 is going to be 7, and it's going to be 70,000. And 9 times 10 to the power of 7 will be 90 million. And so when you add them together, you get 9007000. Now, if you have access to a calculator, if this is on the calculator paper, then you can just type it into your calculator. Some people think there's a quick way of doing this, like adding the 7 and the 9. There isn't. You've just got to work out what this number is, work out what this number is, and add them together. We can't work out what x is straight away, but we can find this value here. And we know with Pythagoras we can find a third length if we've got other two in a right angled triangle. So a squared plus b squared equals c squared. And a and b were labelled. C is always opposite the right angle, so it'd be 49 squared plus b squared equals 68 squared. And 49 squared is 2,401. And 68 squared is 4,624. So we are solving here, so let's get our lines down. And we're going to start by subtracting the 2,401 from both sides. So we've got b squared equals 2,223. Then we're going to square root both sides, and we've got b equal to 47.148, blah blah blah. Okay, we're now looking at the second diagram, and this time we're going to have a, we've got our b, and we're going to call x the c. So it'd be a squared plus b squared equals c squared, but this time a is 39. B we are given as 47.148. We've just worked that out. And we're looking for c. In fact, we can call it x now. Okay, so we need to square that. So we do 39 squared plus 47.148 squared, and that will be 3,744 equal to x squared. And we'll just get our lines in because we need to square root both sides, and we get 61.188 blah 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 is equal to x. It says it wants it to 2 decimal places, so that will be 61.19. So with each of these pools, try and imagine it being filled. So pool A, first of all, we've got water coming into it, and it's actually going to go quite quickly initially, and then it will hit a point at the end where actually it will go really quite slowly because it's a wider pool. So we would imagine that the graph for pool A would actually go quite quickly at the start, and then at the end it would go much slower. And that doesn't really describe, the graph, the red graph doesn't really describe that at all. So for pool B, we start off actually quite quickly, it's quite thin, and then we have a wider bit here, so it will go slower here, and then we go quickly again. So we need a graph that starts off quite quickly, then goes slowly, and then goes quickly. And the steeper the graph on our depth time graph, the faster it's filling up. And that red line doesn't really describe that either. Pool C, however, we can see it goes slowly at the start. And then because it's thin, it will go quicker. So nice quickly. And then it will go slowly again. Well, that is a perfect description of the graph that we're given. So the graph we're given is definitely going to be for pool C. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all. And that's what we call an outlier. So we know that these are going up in twos, so this will be 28, so the x-coordinate will be 28, and this will be 19. So our coordinate will be 28, 19 for our outlier. Integer just means whole number, so we're looking for all the whole numbers that satisfy these two inequalities. Well, the first inequality says that it has to be greater than 3. So the smallest number that is greater than 3 is 4. The second inequality says it has to be less than or equal to 8. So I'm just going to keep going until I get to a number that is less than or equal to 8. It can't be 9 because 9 is not less than or equal to 8. So our answer is 4, 5, 6, 7 and 8. So the first thing we're going to do is work out the area of the trapezium. And the formula for that is half brackets a plus b times h. Now a and b have to be the parallel sides. So here we've got the two parallel sides here. Just pick a different colour. Here and here. So that is a and b. And then the h is the perpendicular distance between them. So perpendicular means it hits it at right angles. So that's what we've got here. So the area would be half times A, which is 28, plus B, which is 14, times the height, which is 14. And so that would be 294. Next we'll do the circle. Now it doesn't look like we've got anything for the circle, but actually the height here is actually the height of the circle as well. So the height of the circle is the same as the diameter. So the diameter of the circle is 14. Therefore the radius would be half of that, which is 7. And the area of a circle is pi times the radius squared. So it would be pi times 7 squared, which will be 153.938 blah blah blah. Now keep that in my calculator, because next thing we'll do is the shaded area part, and it says we want to work out the area of the shaded region. So the area will be the total area, which will be the trapezium, take away the area that we don't want, which is this bit here, which will be the circle. So the trapezium's 294, the circle's 153.93 blah blah blah. And when you do that, you get 140.061, blah, blah, blah. It says it wants it to 2 decimal places, so it would be 140.06. To answer this question, we need to know what an equation, expression, formula, and identity is. So the formula is basically an equation, but for real-world things. So area equals pi r squared. It's where the letters actually mean something. Expression is just algebra without the equal sign, so 5x plus 3 would be an expression. An equation has an equals and it can be solved, so you can find out what x is or find out what a is. And an identity is true for all values of that letter. So an example would be x times x equals x squared. That's an identity because that's true for all values of x. So looking here, on the right-hand side, we've got 3x plus 2x. But if we imagine x is 10, So 3x would be 30 plus 2x would be 20, 30 plus 20, well that will equal 5x, 5 times 10. And actually this is true for all values of x. And the reason it's true for all values of x is we know that 3x plus 2x, this right hand side here, equals 5x. They're the same thing. Now normally with an identity, it's shown with 3 lines. Now in the exam, this type of question, it won't be shown with 3 lines because that kind of gives it away that it's an identity. But this question is definitely an identity. And you can't solve it because it's true for all values of x. So yes, x could be 10, x could be a million, x could be a third, x could be anything. To find the largest weight this package could have been before it was rounded, let's do a quick number line. And we're going to just do it between the 24 and what it would round to next. Well, it's to the nearest kilogram, so the next thing it would round to is 25. The cutoff point for rounding is here. And that's going to be halfway between 24 and 25, which is 24.5. And that is actually going to be our answer. Now, some of you who are astute might realise that 24.5 would round to 25, but theoretically the biggest it can be is going to be 24.49 recurring. Let's just draw that a bit better, 24.49 recurring. And that is actually the same as 24.5. In your exam, however, you can write 24.49 recurring and you would get full marks, but for brevity, I would definitely recommend writing 24.5. So to find the area of a rectangle, we just multiply the width and the length. So that's what we're going to do here. But whenever you have an expression representing a length or a width or anything really, you just put brackets around it. So we go u minus 2 times u plus 9. Okay, and the way we do this is with our grid. And just going to draw out the grid. And so we've got u minus 2, and we're multiplying it by u plus 9. Don't want too many for some reason. And so we've got u times u, which is u squared, u times minus 2, which is minus 2u, 9 times u, which is 9u, and 9 times minus 2, which is minus 18. And what we're going to do is we're just normally going to be able to add these ones together. So our answer will be u squared, and then we're going to do 9u plus minus 2u. Well, that's just going to be 9u take away 2u, which is 7u. So plus 7u, and then minus 18 at the end. To convert from meters to centimeters, we times by 100. But here we're asked to convert between meters cubed and centimeters cubed. So we times it by 100 per dimension. Meters cubed and centimeters cubed is volume, which is 3 dimensions. So what we do is we times it by 100 3 times, times 100, times 100, times 100, or times by 100 cubed. So we get our amount, 0.15, times it by 100 cubed, and that will give us 150,000. So our answer is 150,000 centimeters cubed. Whenever we do these kind of questions, it's always best to convert the pattern into numbers. So we're just going to count the dots. So we've got 2, 4, 6, 8, 9 in the first one. 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So our sequence is going 9, 13, 17. And we're going to see what it's going up in. So we're adding 4 each time. And that means our sequence will involve 4n. And then what we do is we go backwards 1 to find the 0th term. So we're going to take away 1. So 9 take away 1 is 5. So the 0th term is 5. And the 0th term just tells us what to add on to the 4n. So 4n plus 5 will be our answer. So for this question, what we need to do is factorise 4t plus 6. Now factorise means put it into brackets. So if I try, what I can do is I can actually put a 1 on the outside here. So 1 times 4t plus 6 is 4t plus 6, but the question clearly states that it is higher than 1. So we need to find another number that's higher than 1 to factorise this with. So if we look at 4t and 6, well, they're both in the 2 times table. So I can put a 2 on the outside here. 2 times 2t is 4t, and 2 times 3 is 6. So what we can do is we can just check that out with smiles and rainbows. Put all my times down there to remind me to times it. So 2 times 2t is 4t, 2 times 3 is 6. So that works because that is the same as this in the question. So we know that 2 times 2t plus 3 works. In fact, it's the only one that works with it being an integer. So we therefore know that the known side, because it says it's a known number, is 2. And the other side will be 2t plus 3. And then when you multiply them together, you get the area of 4t plus 6. So our answer, because it says the length is the known number, so that's the length, then we're finding the width, which is this one here. So it's 2t plus 3. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 7t to both sides. So we're trying to get x as the subject. So we're trying to get x on its own. And we're next going to divide both sides by 7. So we have m plus 7t, all of that over 7 equals x. So x equals m plus 7t over 7. So for this question, we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around, and it could be distorted, but it basically goes down to a point along here. It goes to infinity, and it goes to infinity along a point over here, and obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down, and this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down, but here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. The important thing when choosing a sample is that everyone has an equal chance of being picked. So if you look at method 1, picking the first 30 students who enter the school is going to have a bias, because there might be a difference in the type of person who arrives early to school to the type of person who might arrive later. If we select a class in the school, then they're generally all going to be the same age. So if it's a year 7 class or a year 11 class, they're all going to be the same age. It might seem that it's fair that picking the first 30 students alphabetically, so A to F or whatever, again, that's not fair, because the people at the end of the register don't have an equal chance of being picked. So you need to make sure everyone in your population has an equal chance of being picked. So picking 30 students out of a hat containing all the students' names in is definitely the fairest way of picking a sample from this list. When finding a sample of people, you want everyone in the population to have an equal chance of being picked. So in method 1, the fact in a lifestyle magazine might bias the people reading it, because there's groups of people that don't read lifestyle magazines. A poster up in the gym, again, there's groups of people who don't go to the gym. And midday in town centres, well, it might be on a school day, or it might be that you are skewing your data towards retired people. There's lots of reasons why a certain group of people won't be at a town centre at midday. The only one here that gives everyone an equal chance of being picked is this one here. Okay, so picking people randomly from the electoral roll. There are some groups of people who might choose not to be on the electoral roll, but looking at the 4 methods, this one is by far the most fair sample. So the first thing we need to do is work out the mean for the data in the table. So to start off doing that, we're going to work out the midpoint of each group. So we've got 80 to 85, and to find the midpoint, you add the 80 and the 85 together, then you divide by 2. So this will be 82.5, then 87.5, then 92.5, then 97.5, and then finally 100 plus 105 divided by 2 is 102.5. Next we need to find the FT, which is just the frequency times the duration of calls. Now, in this first group, we're not timesing it by 80 to 85 or anything like that. We're timesing it by the midpoint. So our midpoint effectively becomes the T. So we're going to do 15 times that, which will be 1237.5. And we're just going to keep going and multiplying each of these together. And then finally 2050. Right, next we need to add up the frequencies and add up the FTs. So we're going to have the sum of the frequencies. So I'm just adding all this column up, and that will be 80. And we have sum of the FT. And so we're going to just add this column up here. And so that would be 7,450. So what this column represents is all the numbers added up together. This column represents how many numbers we have. So to find the mean, it's all of the numbers added together, which will be 7,450, over the amount of numbers we have, which is 80. So when you do that, we get 93.125. Now this question is about the improvement that we've made, or that the manager has made, the call centre's made. So we're looking at subtracting the 93.125 away from the last week, which was 105. So we're looking for improvement. And we're going to do 105, take away the 93.125. And that's going to be 11.875. Now it does ask for 2 decimal places, so that will be 11.88. To find the error interval, I'll start by just drawing a number line, and we're going to put the number in, so 50.14. And we're going to think to ourselves, well, what would the next number down and the next number up be? Well, it's the nearest hundredth of a gram, so the next number down would be 50.13, and the next number up would be 50.15. Then to find the lower bound and the upper bound, or the highest and lowest it could be, we just find the halfway points between those two. And so the halfway point here is 50.135, and the halfway point here would be 50.145. So the lowest it could be is 50.135, The highest it can be is 50.145, and it asks us to use W for the weight, and we're going to show this with inequalities. Now it can be 50.135, so it's larger than or equal to 50.135, but it can't be 50.145 exactly, otherwise it would round to 50.15, so we don't put the line underneath the inequality. So this question is a simultaneous equations question, and so we're going to have to write down some equations. So it says 2 apples and 3 pears cost £3.80. So 2 apples, I'm going to call it A for the price of an apple, plus 3 pears, so 3p, cost £3.80. Now I'm going to do this as 380 just because it's easier to work with integers rather than decimals. And it says 3 apples, so 3a, plus 8 pears costs £7.80, or 780 pence. Okay, so the first thing I do is try and get these numbers the same. So 3 and 8, they both go into 24, so I need to make them both 24. And what some people do is they just label this A and this B. And so what we're going to do here is we're going to multiply everything in equation A by 8, so that this becomes 24. So it's going to become 8a. And so we're going to times the 2a by 8, which will be 16a plus 24p, and 380 times 8 is 3040. And we're going to do the same with b, but this time we're going to times it by 3, so we're going to have 3b. And we're just going through everything here and we're timesing it by 3. So 9a plus 24p, which is good, that's what we wanted. And 780 times 3 is 2340. So now we've got both of these the same coefficient. What we can do is we can eliminate going downwards. Now, if they are the same, the s in same is the s in subtract. If they were different signs, so if these weren't both positive, if one of them was negative, different, the d in different is the d in add. So here they are the same, so we are going to subtract, and we're going to subtract going downwards. So we're going to start off by doing, and I can just do a little line here to show what we're doing. So we're subtracting going downwards, and we're going to do 16a take away 9a, which will be 7a. 24p take away 24p, which is nothing, which is why we did that, is to eliminate them. And then 3040 take away 2340 will be 700. Then I can put my lines in, and all I need to do now is just divide both sides by 7, and I get a equals 100. So we know that apples cost 100, or £1. We need to work out what pears cost. So I just need to pick one of the equations. I'm just going to pick this top one here, and I'm going to write it out. But instead of a, we know that a is £1, or 100 pence. So plus 3p equals 380. So that's going to be 200 plus 3p is 380. And then again, I'm just going to draw my lines down. And we're going to subtract 200 from both sides. So it's going to be 3p equals 180. And then we're going to just divide by 3 both sides. And we've got p equals 60. So a pear costs 60. Now we can check this by using the other equation there. So 3 times 100 is 300, plus 8 lots of 60 is going to be, what's that, 480? So that's going to be 780. So we know that we've got it right. So when we're doing column vectors and adding and subtracting them, we just literally add and subtract the top and bottom numbers. So a plus b minus c will be, just looking at the top, 9 plus 18 minus 9, 9 plus 18 minus 9, which will equal 18. And the bottom will be 9 plus minus 18, so really minus 18, and minus 9, and so that will be minus 18. So our column vector will become 18 minus 18. Okay, so we're going to start off by working out the multiplier, and we're told, we always start off with 100%, we're told that the compound interest rate is 1.6%, so we're going to add 1.6% to the 100%, and it's going to be 101.6%. Okay, make that into a decimal by dividing it by 100, so we're just going to divide that by 100, and this will give us the decimal or the multiplier. So the multiplier is 1.016, and so anytime we want to increase something by 1.6%, we just times it by 1.016. Now, we're told that we start off with 2,400, that's our original amount, and to find out what it's going to be in the savings account at the end of the first year, we just times it by the multiplier, 1.016. But we're told that it's for 7 years that it's going to be in there. So we then times it by 1.0167 times, or easier way of doing it is 1.016 to the power of 7. When we do that, we get 2,682.052 blah blah blah. And because it's money, we round to the nearest pence, so 2,682.05. We're going to start by drawing a table of values. We draw the table of values because we've got a curve here, and with a curve you need quite a lot of coordinates to make sure you get the curve right. Now ideally I'd go up in halves, but so that I'm not just sitting here writing numbers, I'm going to go up in ones on this one. I'm going to leave a space there though, and we'll see why in a second. So what I'm going to do is type these into a calculator. I'm going to type in 0.5 times brackets minus 2 close brackets cubed plus 8 into the calculator, and that gives me the answer of 4. I do the same with minus 1, that gives me 7.5. 0 gives me 8. 1 gives me 8.5. 2 will give me 12. 3 will give me 21.5. The reason I've left a space there is this axis doesn't go up to 21.5. So what I'm going to do is just do 2.5 to see if it goes up to that, and that should be 15.8125. So that's actually quite useful because that shows that it's not quite 16. So we were aiming for roughly where 16 is. So next thing we do is plot these coordinates. So 2 would be at 4. Minus 1 is 7.5, which we can't be perfectly accurate for, but it's roughly there. Then 0 is 8. Then 1 is 8.5, roughly there. 2 is 12. And then 2.5 is just below that 16. So it's almost at 16. Then the next thing we do is just join it up with a nice smooth curve. It's sometimes helpful if you turn your paper sideways. Obviously I can't do it when I'm on this computer, but you want to just keep drawing and don't lift your pen off at all. Just go with the points, and you want to avoid things like feathering, which is like that, where you do that kind of thing, and you kind of want to avoid or you want to make sure you go through the coordinates, and you just make it a nice smooth curve. The exam is very forgiving when it comes to curves. They know that not everyone's got the steadiest of hands, so as long as yours goes through the points and doesn't have like gaps in it or feathering or anything like that, and it's just one continuous smooth line, then you'll get the marks. The formula for the volume of a sphere is 4/3 pi r cubed. So we're going to do 4/3 times pi times the radius cubed, which is 17. And that gives us 20,579.526, blah blah blah. So to 2 decimal places, that would be 20,579.53. There are a few different ways you could answer this question. I'm going to do it with a tree diagram, but you didn't need to draw a tree diagram to answer this question. So we've got our first tree, which is our first bus. And the choices are male and female. And we've got our second kind of branch, I suppose. And it's still male and female. And this is our second bus. So the property of male on a first bus is 9/15. And therefore the property of female is 1 minus 9/15, which would be 6/15. Male on the second bus is 7/15. And so female would be 8/15, because they need to add up to 1. And it's independent, so these will be the same. And the question is basically asking what is the probability that both will be female. So to have both female, we need to have gone down this line at the start and then this line again. Okay, so looking at the fractions along the way, it's 6/15 and 8/15. The word "and" in probability means times. So whenever you're finding the probability of getting to an outcome, so this outcome will be FF, because they're both female, you are multiplying the fractions that you go across. So it would be 6/15 times 8/15. So 6 times 8 is 48. And times the bottoms, 15 times 15 is 225. Now you can actually cancel that down. So what you can do is you can divide top and bottom by 4. And that will give you 16. Is it 4? No. You can times top and bottom by 3. And that would be 16/75. So either 48/225 or 16/75. So what I'm going to do is work out how I get from my centre enlargement to each of the vertices on our shape. And so I'm going to pick the bottom left one first. So we go 1, 2, 3, 4, 5, 6 jumps to the left. Now with a scale factor of 1/3, instead of 6 jumps to the left, it's going to be 1/3 of that for our new image. So instead of 6 to the left, it's only going to be 2. So our new point will be here. And we're going to do the same to the top left one. This is going to take a bit of time, but that's fine. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So instead of 12 up, we're looking for our new one to be 1/3 of that, which would be 4. So 1, 2, 3, 4. So it would be on the x-axis. And we go 1, 2, 3, 4, 5, 6 to the left. And again, instead of 6 to the left, it's going to be 1/3 of that, which would be 2. So our new point will be here. And so if we draw in the new shape, let's make sure we try and do it as neat as possible. Then it will be this bit here. It says to label it B, so we'll put a B on it. So here we've got a right angle triangle and we've got 2 lengths and an angle involved, so it's going to be trigonometry that we're going to be using. And the first step of trigonometry is label the sides. So the one opposite the right angle is the hypotenuse, opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. So here we're going to cross out the hypotenuse because it doesn't have a number or a letter next to it, so we're not using it in this question. Next thing we're going to do is write out our triangles, our SOHCAHTOA triangles. So we're going to have SO, actually I normally put this in purple, so why not? SO, CA, and TOA. And we cross out the H, so it's not going to be SO, and it's not going to be CA, so it's a TOA question. And TOA is short for tan x equals opposite over adjacent. And our angle is actually x, so when we substitute in the values, it's going to be tan x equals, and the opposite is 6.3, and the adjacent is 3.2. And we're going to put our solving lines in. We'll get x on its own, and to do that we're going to do the opposite of tan both sides, which is called the inverse tan. So we're going to do the inverse tan both sides, and to do that what you do is you press shift or second function tan on your calculator, and then we get x equals, so the inverse tan 6.3 over 3.2, which is going to be 63.072 blah blah blah, and to two decimal places it will be 63.07. So what's happened here is that the company's increased the amount of sweets by 15%. So we're just going to focus on that and work out what the multiplier would be first. So they started off with 100% and they added 15%, and then therefore they ended up with 115%. And to find that as a multiplier, we get the 115 and divide it by 100, and that gives us 1.15. So that is the multiplier they used. Now they used that multiplier on the original amount, and they times it by 1.15, and they got the answer of 69. But if we're working the other way to find out what they times by 1.15, we get that 69 and we divide it by the multiplier. So if we want to work out what the original number was, we divide it by the multiplier, and that gives us 60. So the answer will be 60. The equation of any straight line can be written as y equals mx plus c. So we need to find the gradient, which is m, and the y-intercept, which is c, for this line. Now, we are given a clue. We're told that it's parallel to this equation here, but we're not really interested in the plus 5 at the end. What we're interested in is what the gradient of this line is, which is 11, because all parallel lines have the same gradient. So we actually know what the gradient is for the line we're trying to work out. It's going to be the same because it's parallel, so it's going to be 11. So all we need to do now is find out what that plus c is. And what we're going to do is we're going to substitute in the values of x and y for the coordinate we're given on the line. So it's going to be 46 equals 11 times 4 plus c. And we just need to solve this. So first thing I'm going to do is just times the 11 and the 4 together to make 44. And then I'm just going to take away the 44 from both sides. So we get 2 equals c, or c equals 2. And we can put that into our equation. And that is our answer. So it's going to be 11x plus 2. So I'm just going to write this out again, just so we've got a bit more space. Okay, the way we solve this is very similar to solving an equation with equal signs, but this time we're going to do two tramlines because there's three sides of this inequality, and we need to get x on its own. So looking at the fact that we've got 3x plus, or 3x minus 5, we're going to deal with that minus 5 first. So we're going to add 5 to all three sides. So add 5 here. So we'll just leave 3x in the middle and add 5 to the right hand side. Now we need to get rid of that 3, so we're going to divide by 3, and again we need to do it all three sides. So divide by 3 and divide by 3. So we've got x is greater than or equal to 7, and then we've got 10 is greater than x on the right hand side. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.